You're going to miss it for a long time now. Here we go. Okay, you got to have your card. Folks, if you come in here on Thursday with no card, that's bad. That's real bad. Okay? We are going to be looking at simplifying trig identities. Okay? And you have to have your card in order to do this. Why are we going to be simplifying trig identities? We've got to be able to transform equations into a format that we can deal with to get us ready for calculus. Basically, that's why we have to do this. This is getting you ready for calculus. The number one thing I need you to remember is assume that all denominators do not equal what number? 0. Somebody said it. They do not equal 0. Okay? If they do, then what kind of number are we talking about? Undefined. So it's always assume in these problems that your denominator is not equal to 0. Now, no, you don't do anything. I'll tell you when to put it on the card. All right, so we're going to revisit some reciprocal identities. And you ought to be able to remember these. If you learned them, you will remember them. If you didn't learn them, then oh well. Cosecant theta, it's the reciprocal for which trig function? It's 1 over sine theta. This needs to all go in your notes. 1 over sine theta. And then we dealt with secant, which is going to be equal to what? 1 over cosine. Yep. And then cotangent, which is 1 over tangent theta, right? What's another way that I can write tangent of theta? What divided by what is tangent? That sine divided by cosine. These are like different names for all of these trig functions, okay? You've got the tangent, and then you've got one more, cotangent. Cotangent, we already know because of the reciprocal identity, is 1 divided by tangent. However, what's another way we could write cotangent? Cosine over sine. So right now, the one that has the most number, no, which of those trig functions has the most different names? Different things that it's equivalent to. Which one? Yeah, but of those reciprocal identities, which function has the most number of different names? Cotangent does, because it can be 1 over tangent, it can be cosine over sine. It's kind of like, and I use this analogy all the time, how many names do I have? Depends on who I'm talking to, right? Because you guys are going to most likely call me Miss Perry. My kids are going to call me Mom. My mom, my sweet mama. What's my mama going to call me? Hopi, till the day she draws her last breath. God bless her. But I've got 3 different names, and that's not including all the other names that people like to call me. Okay? But I would be cotangent. I'm the same person, same function, but it's called different things. And we use different ratios in different situations. If we're in this classroom, some of you I've known a long time, But if we're in this classroom, what are you going to call me? You're going to call me Miss Perry, because some of you I have known a long time. Some of you, maybe not in this classroom, but in other classes, some of my students have grown up with my kids. So they've never called me Miss Perry until they walked through my door. You understand what I'm saying? So a different name for a different situation. Does that make sense? Now, how are we going to use these identities? This is how we're going to use them. We're going to start where we started. What was the very first thing you put on that card? I want you to put this in your notes. What is that the equation for? The unit circle. Where did it all start? It all started for us in this course, x squared plus y squared equals 1. And then we took a baby step. And we turned x squared plus y squared equals 1 into what? Cosine squared theta plus sine squared theta is equal to 1. That's when we realized that our x value was really now our cosine value, and our y value in an ordered pair is really our sine value. So this is when we started actually working with trig, okay? This is called a Pythagorean identity, okay? A Pythagorean identity. Now, here we go. What if I wanted to find what sine squared is equal to? I need you to think algebraically. Algebraically, what is sine squared theta equal to? Refer back to this one. No, easier than that. Oh, so all I need to do is just subtract cosine squared from both sides. Yeah, that's all you need to do. That's it. Okay? Think. Go back to the original, because this is the one where, this is the important one. Then how would I solve for cosine squared? Subtract sine, so that cosine squared theta becomes what now? Go back here. 1 minus sine squared theta. Right? Y'all with me? Now, I can derive the rest of them. Do you care? Let's just be honest. Do you care to see them derived? What do I mean by derived? Yeah. Do you care? Let's be honest. No, I know you don't. So, if you want to look at that up, you look that up on the computer. Bring it into me, okay? Might give you some extra credit points. But here's the rest of them. Here are the rest of them. Tangent squared theta is equal to secant squared theta minus 1. Okay? And then I'm going to go back. Sine, cosine, tangent. You see how they're always in order, right? Yep. If I were to derive it and to show you how I get that equation, you would understand why it's minus 1. I can if I look back in my notes. Can I show you later? Because I'll have to go, let me get through this, and then yes, I will show you. Okay? Tangent squared, here we go. Cosecant squared theta is equal to cotangent squared theta plus 1. So we got cosecant, we got secant squared theta, which is tangent squared theta plus 1, and cotangent squared theta is equal to cosecant squared theta minus 1. Now, all of those go on your card. You must have this in your notes and on your card, and you need to double and triple check to make sure that you have everything correct first. Because everything you know from algebra ties right into this trig stuff, okay? So in order to simplify, we always should try to factor everything. Then, if we multiply and divide, think about fractions. If we're multiplying and dividing, then we want to cross-cancel factors. This is totally going back to what we just got finished, some of us in Algebra 2, drawing on what we already know from Algebra 1. Okay? You also have to know that if we add and subtract, what do you have to have when we're dealing with fractions? You have to have common denominators. You must have common denominators. Okay, and that's just general algebraic rules. Okay, we follow order of operations. In algebra, we do with this trig stuff. Okay, the same rules apply. All of the same rules apply. When simplifying trig expressions. These are going to be like variables on steroids, because you're not going to be looking at just plain old x now. You might be looking at sine of x and what we have to do to sine of x or to cosine of x or to any of those trig functions. Okay? You got to think, if your algebra skills are strong, then this will be a piece of cake for you. And I bet you that's why I love this stuff. It's like a puzzle for me. Look where we start and then look what we end up with. It's like complex numbers on steroids. Kind of fun. I think I like doing these. Okay? So all of the same rules apply. Now, let's look at our first expression. Does everybody have this? Okay? Here we go. So let's simplify. Simplify means I'm not going to leave anything as two-fourths, right? I'm not going to leave anything as two-fourths. I would reduce it to what? 1/2. So here we go. I'm missing an example. Put everything in terms of sine and cosine. So if I'm reducing from 2/4 to 1/2, if I start out with a tangent or a cotangent or a secant or a cosecant, I've got to whittle it down to where in my final answer I only have sine or cosine. Okay? So look at your first expression. This is so easy. Do not make this difficult. Cotangent theta, sine theta, secant theta. I just want you to look at that. Cotangent theta, sine theta, secant theta. Now, what mathematical operation is connecting all three of those functions. Multiplication. It's there, but it's not there, right? Now, cotangent is not in terms of sine and cosine, is it? How can I rewrite cotangent in terms of sine and cosine? Sine or cosine. Cosine over sine. All I'm doing is substituting. Okay, so here's Miss Perry. Here's Hopi. Okay, it's the same thing, different name. What about sine? Do I need to change sine theta? No, it's already where I need it to be, so we're going to multiply it. Sine theta over who? 1, because now we're dealing in fractions. Y'all know how I love fractions, right? And then what am I going to do with secant theta? What is it? Look at your notes. 1 over cosine theta. That is a reciprocal identity. Now, I got a different color. What am I going to do with this different color? I'm going to start cross-canceling this sucker, right? I'm going to cross out what's first? Sines. Boom, boom. What's next? I could cancel out the ones, but that's kind of defeating the purpose, isn't it? Because I'm just going to go back to it. Don't go with the ones. Go with the cosines, which is only going to leave us with what? 1 over 1, which is 1. Say what? So you're telling me that cotangent theta times sine theta times secant theta is equal to 1. That's it. Is that facile or difficile? That's facile. That's muy facile, see? That is, don't overthink this. So easy. Here's another one. Does everybody see what I did? Yeah? Here's another one. All right, now you know they're going to get progressively more difficult, right? You know that already. Here's another one. That one was easy because we were multiplying. Cosine tangent plus cosine t, my fault. Cosine t plus tangent t times secant t. Wrong, sine t, my bad. Yep, if there's nothing in between them, then they're multiplied. That would be like me just having the variable xy. No, it is multiplied. All right, here we go. Got to simplify in terms of sine or cosine. Can I do anything to cosine? Can't do anything cosine, right? I can put it over 1. How can I rewrite tangent? Sine over cosine. I do. You have to put the t in there because t represents the angle. Very good question. Bless you. How about times who? Times sine t over 1, right? Okay. Now, look where we're headed. We have to follow order of operations. What's the next step? Before that. Follow order of operations. Am I going to add these two fractions or am I going to multiply these two at the end? Multiply. All right, so let's take care of that. Following order of operations, we've got cosine t over 1 plus what? What's my numerator? What's sine t times sine t? Sine squared t over cosine t, right? Cosine times 1 is cosine. Y'all with me? Now what? Now I have cosine plus that thing. I have two fractions. What do I have? What do I have to have when I'm adding fractions? Like denominator, common denominator. What's my common denominator going to be? Cosine over t, or cosine of t. Now, my second one doesn't change, right? Because I'm not doing anything. It didn't change. But if I multiply cosine to the first ratio, then what do I have to multiply to the top? Cosine t times what's already there, and y'all know I'm gonna write this out. You don't have to, but I'm going to. So this is the one we're multiplying. This one comes from our original numerator. What's cosine times cosine? Cosine squared t over cosine t plus sine squared t over cosine t. Now what? I need one numerator over one denominator, don't I? What is my new numerator going to be? Cosine squared plus sine squared over cosine t. Keep looking at that. No, because if we do, then we start chasing our tail. We go back to where we just came from. Look, this is where you're going to hear me squawk like a bird. Card! Look at your card. Why do I want you to look at your card? What is cosine squared plus sine squared? Look, big picture. It's all one. This whole thing is the what? It's 1 over cosine. That's what you've got to look at your card. Look at the what was it, the second one we wrote, wasn't it? And then, what's 1 over cosine? Look at your reciprocal identities in your notes. That one's not on your card. It's secant. Secant t. Folks, look at what you just did. Holy moly. No, it isn't confusing. It seriously isn't. Where? Going from here to here? Going from where to where?
Okay. You said it was the second one on
this one? Yeah. From here to here, that's your Pythagorean identity.
Yeah.
Okay? And then from here to here,
yeah, where did that come from?
Where did this come from? Yeah. Secant t, because it's a reciprocal identity. Look back in your notes.
Okay.
1 over cosine. And folks, that's what you need to do in your notes. I'm going to try not to do this stuff right here. I'm going to try not to write this stuff. That's the kind of thing you need to write on your own. And you need to understand where those values, those expressions are coming from. What we have just done, look where we started. Cosine t plus tangent t sine t. And look where we ended. Secant, for real? No. All of this stuff, this is just my thoughts over here on the right. Trying to guide you through these problems. Sorry.
No, it's fine. I recognize that. Reciprocal identity quotient. I didn't think that was a but we can't write that out on part either.
Nope, you got to know those. You got to know them. And you already do. You really already do know them. Because if you know that secant is the reciprocal of cosine, you know they're tied together, and it's already on your card as inverses at the very top of your card, supposed to be, or it is on India's card. Look back at it. Okay? Shh. Pardon me? Yeah? Right here, Luke? But it's the angle. I'm not squaring the angle, I'm squaring cosine. No, t won't change. Yes. Theta, alpha, beta, whatever we put in there. Okay? Hey, here's what you're going to do, and you are going to do some of this for me. Okay? That's it for today, because look at the clock. What time do we leave? We leave at 1. Oh, no, we ain't done. Forget that. Here we go. Here we go. No, it's all good. You need to do this. You have to remember I only had like 15, 20 minutes to first block. Shh. Do this. Hey, try this one on your own. Oh, look at this. So I want you to think about it. And I don't know if Morgan made a good point. You kind of have to think ahead. What's going to benefit me the most? And I said, what's most advantageous? Look at that $5 word. Y'all proud of me? Now, what's going to benefit you the most? That's basically what that means. Now, cotangent is one of those things that you've got two different ratios. You have 1 over tangent, and then you have cosine over sine, right? Now let's look at this. If I were to put 1 over tangent, I don't want you to write this. Is that really helping me? Because if I change the way this looks into terms of sine and cosine, not really. It really hasn't helped me. So then you have to drop back and punt and go, okay, let's try this something different. And this is where, if you don't use a pencil, you are up the tree without a rope. I don't know what, that doesn't even make sense. Cotangent. What's another way for cotangent? Cosine over sine. Let's think about it. Cosine x over sine x times cosine x over who? Well, when you don't know what to do, put it over 1. Can I simplify sine x? No. So put it over 1. We're dealing with fractions, so I've got to have a numerator and I have to have a denominator. What do I do now? Following order of operations. I multiply. I multiply. What's cosine times cosine? Cosine squared over sine x plus sine x over 1. Well, now I'm just doing what? I'm just adding fractions. You with me so far? Okay? What am I doing now? I'm just adding fractions. What do I do? Common denominator. What's my denominator going to be? Sine. All right, the first one does not change. Okay. Sine x. What did I multiply to the bottom? I multiplied sine x to the bottom, so what do I multiply to the top? Sine x. So I'm going to bring down my original times what I had to multiply, because look, what's sine over sine? 1. Okay. Now, we got to keep simplifying. Cosine squared x over sine x plus, what's sine x times sine x? Sine squared x over sine of x. Hey, I've got like denominators. Ding, ding, ding. What can I do now? Smush them, smush them. How do we spell that? Smell it? How do we spell that? Smush them. Cosine squared. Smush them together. That's how you smell it. And then look at your card. Holy crap, look at your card. Cosine squared plus sine squared. Eventually, you're going to look at that immediately and you're going to go, what? 1. Because it's from the card. 1 over sine x. And then, folks, what is? I don't want that stinking 1 over crap. I want something nice. Cosecant x. Cosecant x. Because it's the reciprocal. What do you think about? How many of you had cosecant x? Hands up. Now, let me tell you something. Okay? Hands up. Hands down. Try 1 through 6, because if it looks like a difference of squares, then factor it like it's a difference of squares. If it looks like you can factor out a GCF, then do that. If it would be easier for you to go old school on the division problem, then go old school. Okay? You don't have to have a fraction over a fraction. But you look at that, and I expect it to be done when you come in here tomorrow. No questions asked. Okay? No games today, so you can't use that as your excuse. Yes, sir.